Another day, another story. According to most paleontologists, birds branched off of one of the main dinosaur lineages more than 100 million years ago. Numerous dinosaur fossils show that dinosaurs did indeed have teeth, but why are modern birds toothless? What happened to birds between then and now to make them this way? Well, there are numerous explanations. For example, a bird's lack of teeth was thought to be an adaptation that allowed these animals to pursue their prey, such as worms, insects, and vertebrates, and consume seeds and nuts a bit easier, since they did not have to contend with a beak full of teeth. In addition, the lack of teeth made the birds lighter, perhaps making flight that much easier. Welcome to Tabo Eminent Channel. More recent research, however, has called these explanations into question and proposed a new explanation. Teeth, it seems, take a long time to come together while an animal is developing within an egg. Using tooth development in dinosaurs for comparison, this process could take up to 60% of a bird's incubation time. So, dispensing with teeth altogether may have allowed birds to develop and hatch more quickly and spend less time in a vulnerable, immovable state. Many of today's bird species hatch within weeks or even days of the eggs being laid, whereas dinosaurs developed within eggs for several months. Now, what if it's said that birds do have teeth? One of the last known birds to have something close to what could be called true teeth was Ichthyornis, a genus that lived more than 66 million years ago. Subsequently, most birds in their pre-hatched state have grown something called an egg tooth, a tooth or tooth-like structure used by the young of many egg-laying species to break the shell of the egg and escape from it. Some lizards and snakes develop a true tooth that projects outside the row of other teeth, but birds, and many other egg-laying animals, have an analogous horny structure that performs a similar function. For example, a bird's lack of teeth was thought to be an adaptation that allowed these animals to pursue their prey, such as worms, insects, and vertebrates, and consume seeds and nuts a bit easier, since they did not have to contend with a beak full of teeth. Birds do not have teeth, and this evolutionary adaptation has several advantages that are beneficial for their survival and efficiency. Weight reduction for flight. Teeth are heavy and require a strong jawbone and associated muscles. By losing teeth, birds reduce the overall weight of their heads, making flight more efficient. This weight reduction is crucial for maintaining the energy efficiency necessary for flying. Improved balance and aerodynamics. A lighter head improves a bird's balance and aerodynamic shape, further aiding in flight. The streamlined shape of a beak is more aerodynamic than a jaw full of teeth. Specialized feeding mechanisms. Birds have developed a wide variety of beak shapes and sizes suited to their specific dietary needs. Beaks can be highly specialized tools for different feeding strategies, such as cracking seeds, sipping nectar, catching fish, or tearing flesh. This specialization allows birds to exploit a diverse range of ecological niches. Digestive efficiency. Instead of chewing food, birds have a specialized digestive system with structures like the crop and gizzard. The crop stores food temporarily, while the gizzard, often containing ingested stones, grinds the food mechanically. This system allows birds to process food efficiently without the need for teeth. Evolutionary history. Birds evolved from theropod dinosaurs, which had teeth. Over time, the ancestors of modern birds gradually lost their teeth as they adapted to different ecological roles. This evolutionary trajectory led to the development of beaks and other adaptations suited to the bird's diverse lifestyles. The story of why birds don't have teeth is a fascinating tale of evolutionary adaptation and survival. It begins in the Mesozoic era, a time dominated by dinosaurs. Among these dinosaurs were the theropods, a group that included formidable predators like Tyrannosaurus rex as well as the ancestors of modern birds. These early theropods had teeth, which they used for hunting and eating. From dinosaurs to birds, the evolutionary journey. About 150 million years ago, during the late Jurassic period, some small theropods began to exhibit features that we now associate with birds. These features included feathers, which were likely initially used for insulation and later adapted for flight. Archaeopteryx, often cited as one of the earliest known birds, lived around this time and had both teeth and feathers. As these bird-like dinosaurs continued to evolve, they gradually lost their teeth. This process wasn't sudden but occurred over millions of years. The transition from teeth to beaks marked a significant evolutionary shift, allowing these creatures to exploit new ecological niches and food sources. The benefits of losing teeth. Weight reduction. Flight is an energetically demanding mode of locomotion. Every gram of weight matters. Teeth, along with the strong jawbones and muscles needed to support them, added unnecessary weight. By losing teeth, early birds could become lighter and more efficient flyers. Enhanced aerodynamics. A beak provides a more streamlined profile than a mouth full of teeth. This aerodynamic shape reduces air resistance during flight, allowing birds to fly faster and with greater agility. Specialized beaks for diverse diets. The development of beaks allowed birds to specialize in a wide range of feeding strategies. For example, hummingbirds have long, slender beaks ideal for sipping nectar from flowers. Hawks and eagles have sharp, curved beaks perfect for tearing flesh. Woodpeckers have strong, chisel-like beaks for pecking into wood to find insects. Efficient digestion. Instead of chewing, birds swallow their food whole or in large chunks. They rely on a muscular organ called the gizzard to grind up their food. Many birds swallow small stones that help the gizzard break down hard food items like seeds. This digestive strategy allows birds to process their food effectively without the need for teeth. Fossil evidence and genetic studies. The fossil record provides clear evidence of the transition from toothed to toothless birds. Early bird-like fossils, such as those of Ichthyornis and Hesperornis, show a mix of modern and ancient features, including toothed jaws. As we move forward in time, fossils of birds like Confuciusornis show beaks without teeth. Genetic studies have also shed light on this evolutionary process. Research indicates that the loss of teeth in birds was likely due to mutations in genes responsible for tooth development. These genetic changes were favored by natural selection because they provided advantages for flight and feeding. Modern birds, a testament to evolution. Today, birds are among the most diverse and successful groups of animals on Earth, with over 10,000 species adapted to almost every environment. Their toothless beaks and specialized feeding strategies are key to this success. From the soaring albatrosses of the open ocean to the tiny, hovering hummingbirds of tropical forests, the story of birds' beak evolution is a testament to the power of natural selection and adaptation. In summary, the story of why birds don't have teeth is one of remarkable evolutionary innovation. By shedding their ancestral teeth and developing beaks, birds have become one of the most diverse and adaptable groups of animals, capable of thriving in environments ranging from Arctic tundras to tropical rainforests. The absence of teeth in birds is a result of evolutionary adaptations that enhance flight efficiency, balance, aerodynamic performance, specialized feeding strategies, and overall survival.